The surface tension breaks. Gravity pulls downward. But a man stands, the Sea of Galilee beneath his feet, not sinking, not drowning, just walking, as if the water itself became solid stone. How is this even remotely possible? One of history's most documented miracles defied every law of physics we know. Jesus Christ walked on water, not across ice, not on hidden platforms, but on a stormy, turbulent sea in the dead of night. But the real question isn't whether it happened. The real question is, what kind of force could suspend the fundamental laws of nature itself? Today we spend billions on hydrofoil technology, hovercraft systems, magnetic levitation, just to achieve what one man did with a single step 2,000 years ago, with nothing but his presence, no machinery, no propulsion, no scientific apparatus, just footsteps on liquid water. Yet when modern physicists examine this event, they don't dismiss it. They freeze, because what happened on the Sea of Galilee that night violates molecular physics, thermodynamics, gravitational constants, and every principle of fluid mechanics. Some call it myth, others call it metaphor, but engineers who study the hydrodynamics of Galilee know something unsettling. If this event occurred, as recorded, we're not looking at a miracle that breaks the laws of physics. We're looking at something that commands them. If you're ready, we're stepping onto the water. The Sea of Galilee, known in ancient times as Lake Kinneret, sits 213 meters below sea level. It's a freshwater body roughly 21 kilometers long and 13 kilometers wide, surrounded by hills that create unpredictable wind tunnels, and these winds descend rapidly, whipping the surface into violent storms within minutes. Fishermen of the region knew this. They respected it, they feared it, and on one particular night, they experienced it firsthand. The Gospel accounts place this event during the fourth watch of the night. Between 3 and 6 a.m., the disciples were crossing the lake in a boat fighting against fierce winds. The waves were high, the boat was straining, and then through the darkness and the spray, they saw a figure walking toward them on the surface of the water. Not swimming, not floating. Walking with steady, deliberate steps. Peter, in a moment of impulsive faith, called out, asked to join him, and for a brief, impossible moment he did. He stepped out of the boat, and he too walked on water, until fear gripped him, until doubt shattered the moment, and he began to sink. But here's where the physics become undeniable. This wasn't calm water. This was a storm. Waves were crashing. The surface was in constant motion, turbulent, chaotic, dynamic. And for anyone to walk on such a surface, even if some natural phenomenon provided temporary support, would require not just molecular stability, but kinetic perfection. And that brings us to the scientific problem. Water, at the molecular level, is composed of hydrogen and oxygen atoms, bonded in a polar structure. This polarity creates surface tension, a force that allows small insects to walk on still ponds. The surface tension of water at 20 degrees Celsius is approximately 0.072 newtons per meter. This tension can support lightweight objects with large surface areas, like water striders, whose legs distribute their minimal weight across a broad span. But an average human weighing 80 kilograms creates pressure far beyond what surface tension can sustain. For a human to walk on water without sinking the surface would need to resist a force of roughly 784 newtons, the equivalent of the person's weight multiplied by gravitational acceleration. Surface tension under natural conditions cannot provide this resistance. The molecular bonds simply cannot hold. The pressure from a human foot concentrated on a small area breaks those bonds instantly, and the person sinks. Some researchers proposed the spring ice theory, suggesting that cold underwater springs in the Sea of Galilee could create patches of ice on the surface, thin, invisible layers that might support a person's weight. This theory gained attention. It was published, it was discussed, and then it was dismantled because the Gospel accounts specify a storm, strong winds, crashing waves. Ice, if it existed, would fracture immediately under such conditions. And even if it didn't, walking on thin ice during a storm is exponentially more dangerous than walking on liquid water. Moreover, ice formation requires sustained cold temperatures. The Sea of Galilee, even in winter, rarely freezes, and certainly not during a storm. The theory collapsed under its own weight. Another hypothesis involved non-Newtonian fluids, substances that change viscosity under pressure. Cornstarch mixed with water, for example, becomes solid when struck, but liquid when left undisturbed. Could the Sea of Galilee, under specific conditions, behave like a non-Newtonian fluid? The answer is no. Freshwater lacks the suspended particles necessary to create such behavior, and even if it did, the effect would be instantaneous and localized. It would not provide sustained support across multiple steps, and it certainly wouldn't allow another person, Peter, to replicate the action. The hypothesis fails. Then came the most audacious proposal, that Jesus walked on a submerged sandbar, a shallow ridge just beneath the surface, hidden from view but providing solid ground. This theory assumes the disciples, experienced fishermen who knew every contour of Galilee, somehow mistook shallow water for deep water in the middle of a storm at night, and that Peter, stepping out of the boat, also happened to land on this perfectly positioned sandbar, and when his faith wavered, he coincidentally stepped off it. The improbability is staggering, and the gospel text contradicts it. When Peter began to sink, Jesus caught him. The narrative describes sinking, not stumbling. Sinking into deep water. Every naturalistic explanation unravels, because none of them account for the core physical reality. A human body under normal gravitational conditions cannot be supported by liquid water. The density of water is 1,000 kilograms per cubic meter. The density of the human body roughly the same, which is why humans float partially submerged, but do not stand. To walk on water, a person would need to move fast enough to create dynamic lift like a skipping stone. The speed required according to kinetic physics is approximately 30 meters per second. That's 110 kilometers per hour. A full sprint continuously on an unstable surface. But the gospel describes a calm, steady walk, not a frantic dash. So, we return to the central question. What kind of force could alter the molecular behavior of water, suspend gravitational pull, and allow a human being to walk across a stormy sea as if it were solid ground? The answer lies not in the properties of water, but in the nature of the one walking on it. This wasn't about exploiting a loophole in physics. It was about authority over the system itself. Modern science operates on the assumption that natural laws are inviolable, consistent, unchanging, and in the vast majority of cases they are. But this assumption rests on a philosophical foundation, that nature is self-governing, that no external force can intervene. Yet, if the one who designed the molecular structure of water, the one who set gravitational constants, the one who established the laws of thermodynamics, were to step into his own creation, those laws would not break. They would obey, not because they were violated, but because they were commanded. When Jesus walked on water, the water didn't become ice. It didn't turn into a non-Newtonian fluid. It didn't reveal a hidden sandbar. It simply responded to the presence of its creator. The molecular bonds, the gravitational vectors, the surface tension, all of it remained intact, but it was overridden by a higher authority. The laws of physics describe how nature behaves under normal conditions, but they do not account for the presence of the lawgiver, and that distinction changes everything. Peter's brief success and his subsequent sinking reveals the principle at work. When his focus remained on Jesus, the same authority extended to him. When his focus shifted to the storm, to the impossibility, to the fear, the natural laws reasserted themselves, and he sank. This wasn't about Peter's strength or skill. This was about connection to the source of authority, and when that connection wavered, so did the miracle. From an engineering standpoint, the event on Galilee represents a localized suspension of gravitational pressure. The water beneath Jesus' feet did not collapse under his weight because the force exerted downward was met with an equal opposing force from below, not from the water itself, but from the one commanding it. In thermodynamic terms, this would require an energy input far beyond human capacity, an energy source external to the physical system, which is precisely what the gospel claims: divine intervention. But the implications extend beyond this single event. If the laws of nature can be commanded by their creator, then miracles are not violations of science. They are demonstrations of a higher reality, one that science can observe, measure, and document, but cannot fully explain because the explanation lies outside the material system. This is why the walking on water remains one of the most scientifically compelling miracles in Scripture. It cannot be dismissed as metaphor. It cannot be explained by natural phenomena. It cannot be replicated by human technology. It stands as a singular event, witnessed, recorded, and impossible by every standard we possess. The Sea of Galilee still exists. Fishermen still navigate its waters. Storms still arise without warning, and the physics remain unchanged. Water still cannot support a walking human. Gravity still pulls downward. Molecular bonds still break under pressure. Yet for one night, 2,000 years ago, the impossible became reality. Not because the laws of physics failed, but because they were overruled by the one who wrote them. The question is no longer whether it happened. The evidence, historical and physical, suggests it did. The question is whether we're willing to accept what that means. The universe, with all its constants and equations, is not a closed system. It has an author, and when the author steps into his own story, the rules don't break. They bow. Perhaps the real issue is not that we find this event impossible. Perhaps the issue is that we've limited our understanding of possibility itself. We assume that because we cannot replicate something, it cannot occur. We assume that because a phenomenon defies our current models, it must be false. But what if the models are incomplete? What if the framework we use to understand reality is missing a variable? The variable of intentional directed power from beyond the system. That changes the equation. It doesn't break science. It expands it. It forces us to consider that the universe is not self-explanatory, that it points beyond itself to something greater. So here's what we can conclude with certainty. The walking on water was not a trick, not a misunderstanding, not a natural phenomenon misinterpreted by ancient fishermen. It was a deliberate act of authority over creation, demonstrating that the one who made the water, who set its molecular structure, who established the gravitational constants, could command it to behave differently for a moment for a purpose. And that purpose was clear: to reveal who he was. Not just a teacher, not just a prophet, but the Lord of nature itself. And if that's true, if the one who walked on water is the same one who set the stars in motion, who carved the mountains, who designed the very fabric of reality, then every equation we write, every law we discover, is not a limitation on him. It's a reflection of him. The universe doesn't constrain God, it reveals him. And when we study the physics of the impossible, we're not dismantling faith. We're encountering the footprints of the Creator pressed into the surface of his own design. Write in the comments,